Hello everyone, welcome back to a new video. In this video, we will be discussing about how to use Prodigy I3C Protocol Analyzer API functions such as application programming interface functions similar to the user interface. The API functions for I3C Protocol Analyzer comes with all the features that are supported on the user interface. Please check out our previous video to know more about the user interface of the Prodigy I3C Protocol Analyzer. So whenever the user installs the software for Prodigy I3C Protocol Analyzer, during that time the DLL library for the Prodigy I3C API functions will also be get installed, and we do have a separate API manual listing out all the functions as per the I3C-EX-PD API, which includes all the APIs that are supported, which are similar to the user interface also. So we will just walk you through one of the sample script for the Prodigy I3C Protocol Analyzer. The I3C Protocol Analyzer supports API functions for both Python and C++. So in this video, we are showcasing only the Python API sample script. So as you can see, in the top of the sample script, we are calling some of the required libraries, and after that we are calling the path of the protocol core module, which is protocol core module DLL library, and below that these are all the some of the import libraries for this particular protocol core module DLL function. And after that we have some of the functions which are similar to the user interface, such as get LED status, which will provide you the LED status on the hardware device, and we have the get node ID, so we basically provide the number of nodes present on the I3C Protocol Analyzer. And also the next function is we have the get device list, which will provide you the number of devices that are configured in the I3C network of the Prodigy I3C Protocol Analyzer. Similarly, we have some more functions to know more about the device parameters. We have the get device parameter, and to start with the emulating the I3C messages using the API, we have some of the sample functions listed down in this particular sample script, such as load script ENTDA. So this is to do the I3C initialization with the targets to assign the dynamic address, and we have the IBI script also to generate the IBI from the Prodigy target, and using this particular frequency duty cycle and open drain frequency, the user can configure the open drain timing and frequency parameter and the push pull frequency and timing parameters. And using our API manual, similarly the user can configure different types of functions as per the test requirement also. And also here you can see we are just framing one function with a private write from the master side or a controller side. And we have a get result function, so it gives you the all the results of each particular I3C frames that are captured in the analyzer. And in the next we have the generate report option, as similar to user interface. Here also the user can generate the report either in CSV format or HTML format. So these are some of the functions listed down this particular sample script. Similarly, the user can configure different functions as per the test requirement. To start with the connection and configuration, so here you can see the first one is to check for the connection. Here we have one particular function, and after that we are configuring one controller and multiple slaves, which is like we are configuring 3 slaves. And once the capture gets started, the analyzer on the I3C-EX-PD will get started to capture the waveforms that are coming on the bus. And under this we are calling some of the functions, such as initializing the I3C bus with ENTDA command, and after that we are calling the get result function to know the details of this particular ENTDA frame, and we are sending the IBI to generate IBI from the target side, and we are calling the open drain frequency duty cycle functions to configure open drain timing and frequency parameter, and to configure push pull frequency and timing parameters. there is one more function to set the maximum write length and maximum read length. The user can call all the required functions as per their test scenario under this particular after starting the capture from the analyzer side. Similarly, the user can call the required functions as per their test scenario after starting the capture on the analyzer part. So in the last, we are calling the generate report to generate the report in HTML format, and after that we are providing the reset all. Whenever we provide particularly the reset all function, the device get resetted itself. All the configured nodes such as controller and target will get erased and device will be booted up with a new sequence. So this example is in Python API. So we will just run this script once. As you can see, the connection is successful with the hardware device. And once after the connection is successful, we are sending the ENTDA frame. And here are all the details of the how many controller and targets are added in the network. So after that, here there are the node details for master, slave, or a controller or target. Similarly, in the last, we have the multiple frames that are sent as for this particular set MWL, MRL and private write read frames. And once after all these frames completed, here we are generating the report, and the report gets generated to this particular location, whichever is defined by the user actually. So we will just navigate to the report. As you can see, this is the latest report that is generated. This is how the report looks for I3C EX-PD protocol analyzer. In the top, we will have the project details, and in the bottom, you will have the protocol list. So here you can see, first we sent a reset DA frame, and after that it's the ENTDA. Here you can see the multiple slaves are responding for a ENTDA command. And after that, we are generating the IBA from the target side, and we are issuing the set MWL and set MRL function from the controller side. And after that, we are performing a private write read with one particular target with a dynamic address 08. So suppose if the user want to perform rigorous testing or automate with a particular target duty or a controller duty, the user can use Prodigy API function also, either in C++ or Python API. And all the captured waveforms in the analyzer mode will be saved as a trace capture in this particular location. Whenever the user want to use it for a reference, they can just load this particular trace file in the user interface also. So this is all about Prodigy I3C EX-PD protocol analyzer automation using the API functions on Python and C++. Both the DLL library will be similar for C++ and API. So hope this video is informative. We'll see you in the next video. Thank you.